Hello my great viewers, you're welcome once again to UMass Media for another awesome time. Today we are going to be looking at a special indicial equation. You may not have solved such a problem before, so I want you to follow me closely while I dive into today's class. Okay my great viewers, this is the question we'll be looking at for today. It says solve for n in 2 raised to the power n plus 1 minus 2 raised to the power n all over 3 into 2 raised to the power 2n plus 1 minus 4 into 2 raised to the power 2n minus 1 all equal to 1. Maybe looking complex, but follow me while I simplify it. Now this is a form of indicial equation. I have handled an indicial equation before now. I'll be dropping the link of that video at the description of this video. Do well to check it. Now we learned that in the multiplication law of indicial equation, when the bases are the same, the powers are added. Now we can see here, this is an expression of multiplication law where powers of the same base have been added. So we are going to expand it. We see the same thing in this one here and also in this particular one. Now there's one thing we are going to do before we proceed. We are going to assume 2 raised to the power n to be equal to y. Let 2 raised to the power n be equal to y. Now the next thing I'm going to do is to cross multiply. Because here we have equal to 1, so this is actually an equation, an indicial equation. So this is like having all over 1 here. So cross multiplying in this equation, we're going to have 2 raised to the power n plus 1 minus 2 raised to the power n times 1. And that's going to give us 2 raised to the power n plus 1 minus 2 raised to the power n equal to the whole of these terms in the denominator of this equation. We multiply the one we have as the numerator in the right hand side of the equation, and that's going to give us exactly the same term we have on the down part here. That is 3 into 2 raised to the power 2n plus 1 minus 4 into 2 raised to the power 2n minus 1. Now let us expand this from the knowledge of multiplication law. This is the same thing as having 2 raised to the power n times 2. Because by the time I want to bring it together, apply the law of multiplication, since they have the same base, 2 means I'm going to add the powers, which is n plus the power of 2 here, which is 1. And that will give us back what we have up here. Then I have minus 2 raised to the power n equal to 3 into, I will do the same thing here. I have 2 raised to the power 2n times 2 minus 4 into 2 raised to the power 2n divided by 2. This is division law. You know, when the bases are the same, the power of the numerator will subtract the power from the denominator. And that's exactly what was expressed here. So we are expanding it, and that gave us 2 raised to the power 2n divided by 2. 2 raised to the power n times 2 minus 2 raised to the power n equal to 3 into 2 raised to the power n bracket 2. Now this is power law in expression. I just expanded what I have here, 2 times n, which is 2n, putting it in power form, whereby a base is raised to a certain power and altogether raised to another power. I explained all this in the video I did on the introductory aspect of the laws of indices. I'm also going to drop the link of that video at the description of this video. So that's going to be 2 raised to the power n in bracket 2 times 2 minus 4 into, I will do the same thing here, 2 raised to the power n times 2 all divided by 2. Now let's apply what I have there. 2 raised to the power n equals y. So in place of 2 raised to the power n, I will put y. So I'm going to have y times 2 minus y equal to 3 into y raised to the power 2, because 2 raised to the power n is now y. So I have y raised to the power 2 times 2 minus 4 into 2 raised to the power n becomes y, then we'll have y squared divided by 2. So y times 2 gives us 2y minus y equal to, now what we have inside the bracket here is y raised to the power 2 times 2, which is 2y squared. So 3 times 2y squared is going to give us, 3 times 2 is 6, that's going to be 6y squared. So we have equal to 6y squared minus, now we have, this is y squared all over 2. If the 2 here divides 4, we're going to have 2 left. So this is going to give us 2y squared. Now on the left side of this equation, we're going to have 2y minus y gives us y equal to 6y squared minus 2y squared gives us 4y squared. Okay, proceeding from here, we're going to divide both sides of this equation by y. And if we do so, we're going to have y all over y equals 4y squared all over y. Y cancels here, we have 1 left here. Y cancels y here. So this is going to imply 1 is equal to 4y. Now to find y here, we divide both sides of this equation by 4, the coefficient of y. So I'm going to have 1 all over 4 is equal to 4y all over 4. And if we do that, this will imply 4 cancels 4 here. So we are left with y is equal to 1 all over 4. Remember that when we started, we said let 2 raised to the power n be equal to y. So if we are to bring back that here, we are going to have 2 raised to the power n equal to 1 all over 4. So here we have 2 raised to the power n is equal to 1 all over 4. And this is the same thing as saying 2 raised to the power n is equal to 1 all over 2 raised to the power 2. Because 4 is the same thing as 2 times 2, which is 2 raised to the power 2. Okay? Now, this is the same thing as saying 2 raised to the power n is equal to. Now, this is an expression of the law of negative index, which I talked about in the introductory part of indices that I dealt with in a particular video, which I'll be dropping the link at the description of this video. Now, this is going to be equal to 2 raised to the power minus 2. Now, since the bases are the same, we equate the powers. This simply means that n is equal to minus 2. Wow. We've been able to arrive at the solution of this indicial equation that was looking so complex, but now simplified. Thank you, my great viewers, for taking our time to watch this video to the end. Just in case you didn't understand some aspects of the solution I just gave you, you're free to watch it over and over again, or ask us a question at the description of this video and I will attend to it. In case this is your first time of visiting this channel, I would like you to hit the like button, subscribe to this channel, so that when next you must be post another video, it's going to appear in your notification. And I want you to share this video to your friends and lovers, so that they can as well have access to the same information you have. And I will see you in the next video. Thank you.